recording. All right. I guess it doesn't until I save it out. I'll show it to you. All right. All right. So I'm going to close this up. Oh, by the way, before I get into the lab, I'm going to say that something made a few changes. I said last week, I think I said last week, that I was going to teach from the coast occasionally. So this semester it worked out best to do that the second week of every month. I try to keep it consistent too. Last semester I did the last week of every month. And so that will be next week. So I just got the email back that said that my van reservation went through. So next week and the second week of every month for the rest of the semester, I'll be meeting down there. So you guys will see just virtual me. But I'll still be meeting. We'll still be meeting, but I'll meet from down there, and then again the second week. I forget all the dates. I'll post them if you want.
Dr. Raver, will you still need me down here on those days when you're here?
You don't need to be there, I guess.
Okay, I can be if you need me here. I was just asking.
Yeah, no, I think it'll be fine. You can
Okay.
find something else to do those days if you'd like. All right. So yeah, that'll be next Wednesday, next Tuesday as well. If you're in my Tuesday class, I'll be down there. Okay. So this intersect and union, those were just tests, although those are pretty close to what I want to do, so I'm going to delete them. However, this data set is actually a data set that we want to do, that we want to use, but we're going to talk about a little bit different way of creating it. And let's actually bring up the lab content. So if I go under modules, and I go under, I do have this PowerPoint. You guys can go through that PowerPoint on your own. I don't need to go through it, but it's helpful. It's helpful to learn a little bit about Model Builder. There's lots of help in the ArcGIS system on that too. Okay. All right, so let's stand up for a second. I guess I'll need to narrate that. Okay, we've already done this first step, or maybe you have, maybe you haven't, but I downloaded the data, and the first question there, what type of data is this? That's a real hard question. Right? What type? Is it vector or raster data? Vector. It's all vector data, exactly. All right, and if you paid attention, or if you want to go back in the video, I actually answered the next question during I asked it in class, so you guys should have the answer to that. What is the data format of all of this data that you downloaded? Not this data. This data. Yep. All right. Good. So you got the answer to that question. And then, what are the different layers present for each county? So every county has a set of layers associated with it. And I'm just asking for a brief description of that data. So all of these layers, what do they represent? So you just need like a quick English one word or one sentence answer as to what each of these data sets represent. Okay, not a big paragraph for each, just a little description of what each of those means. Okay. That's what that next question's asking. It's pretty straightforward. All right, so let's get on to the tasks. There's two tasks that we need to do. The first task is to be able to merge a set of data in each county into a single new layer. Okay, by data set I mean the same equivalent layer in each county. So I don't mean to merge all of these data sets. What I mean is I want to be able to merge the equivalent data set, the C chords 35, the C chords, and the C chords data I want to be able to merge those into a new data set that is all together. And then I'm going to do that as a model. Okay, and then, yeah. So we're going to demonstrate it in class doing this as a model. And basically you'll get a passing grade if it works with full credit. And then if you can make your model, using Model Builder, if you can make your model general, then you'll get an A. So basically you get a B if it works. You get an A if you can turn your model into a model that you can just execute, and you choose the layers that you want to do, and it will run those layers and produce a new output. Okay, so I'll kind of show you how to do that, and then that, but a little bit of that will be you working through that in the help. Okay. All right, so we're going to go over that in class now. And then we need to ask the question, what tool would I use to remove the boundaries that are still present after the append or merge? Yeah, exactly. So you're going to do that. You're going to experiment a bit with your merged data set and do that. You're just going to basically try to reproduce what we did in class. And if you can't figure out exactly, the video will be there, so you can go back and watch me do it in class. But I want you to do that for more than just, it has to work on more than just the, I want you to do it so that you can see that it works in more than just the water body data set. Okay? You don't actually need to output all the other data. Okay? You just need to know that you can do it to those other data sets. All right. So then, the next the next question, what parameters do you need to include to keep all the input fields, but also remove the common boundaries? That's actually kind of a trick question, right? Can you keep all of the input fields and also remove all of the common boundaries? Is it even possible? Think about that. All right. Okay. Next thing here, this is the second task that you're going to do. The second task is to figure out how, I already kind of described this, but basically what I want to do is to figure out how much of each public land survey unit, these are squares, is covered by a water body, okay, as a percent, or as a number. I don't actually care which one. So I didn't specify, so I had people turn in both answers last year, so I'll take both answers. So this will obviously involve doing an overlay. I did say percent. I made some changes from last year. You might have noticed if you looked at it today. So I did say percent. So you'll need to output to a table that reports the percent water body in each public land survey unit. That's the only requirement. However, I want in your report every public land survey unit, even if the percent is 0, you need to include it. So you don't need to make a model of that process because you're really only going to run a few tools to do it, but you do need to give the answer. So, so your inputs are going to be the merged data from the output of your first model, though, for the public land survey and the water bodies. Okay. So which overlay operation should you choose? Union or intersect, and why? You can answer that. Maybe we'll kind of answer it when we get to there. So what are you going to turn in? You're going to turn in the answers to all these questions, like in a Word document, or I don't even care if it's just a text file and you open in Notepad or whatever. You turn in the answer to all those questions. You also need to include a table with the percent of each PLS covered by water, by a body of water. So the table can just be a table that you export from ArcGIS. And then each public land survey has to be included because it's not covered in a water body at all. And finally, you're going to turn in your model. That's actually from the first task that merges and then removes the common boundaries from layers in general.
So just the model.
Just the models.
Okay.
We're going to build the model inside of the toolbox. So you'll notice we actually already built a model. That's this model right here. And if I go to the toolboxes for today's lab, it actually put that model in there. So that model that I created right here, it put it right there. And I'll kind of go over a little bit of this when we right now, when we do the first part of this lab, because we're going to do this mostly together here. All right, so I'm going to go ahead and delete this other model because I never actually used it. Okay, so I've got this model, and I don't really need that model, but I can leave it there. There's no problem with it being there. So I'm gonna go ahead and save this whole project before I get too far. Save. Okay, so we want to create another model. So we go to Analysis and Model Builder. So here I am. I want to create my model, and I kind of structured the assignment so that I wanted you to create a specific model that did a specific thing, and then I want you to make it general. So that's the way we're going to work through it in the lab. Okay? We're going to first do a specific model that does a specific thing, and then we'll try to make it general. So what does it need to do? Well, it first needs to merge 3 data sets, right? I lost my tool. There are my tools. Okay, so I need to drag on the merge tool. So I got the merge tool. Oops. I need to drag that one on here. So I've got my model and I've got my merge tool in here. And that represents running a merge. If I click into the merge tool, it has what as the input data set? It allows me to put multiple input data sets as an option. And what do I want to merge? We already did the water bodies, right? So just for fun, let's do the PLS data, okay? So I'm going to choose those data sets. So I need to make sure I do it for forest. I'm going to choose the PLS data. It says for public land survey. I don't know if I said that already. And then I'm going to choose the public land service data for Lamar, PLS data set. And I'm going to choose public land survey data for Marion.
How are you? Nothing's showing up on my screen for the model. How did you do that?
I'm sorry.
I had to get it by double clicking on the merge box.
Sorry, what's your question?
I'm trying to do the model. It's not. It's just showing up like blank on my screen. There's nothing.
In the model,
Right.
you drag the merge onto the model builder. Got it? Okay, so that's the merge part of it. So really, the merge part of it's all done. Now, I did say that I wanted you to do the dissolve after the merge. So we'll throw the dissolve on. So we'll throw a dissolve on. And in Model Builder, we can actually connect things by just clicking inside and then dragging out to the other tool. So what this is going to do, if I do this, is I'm going to say, the output of this merge is going to be the input to the dissolve. And if there's more than one parameter, it's going to make me choose which one. I'm going to make it be the input feature. Okay. So now it's going to run the merge, and then it's going to dissolve that. Now, if I click in to any of these data sets, it's telling me where it's going to put it by default. That's where it's going to put it. So these are the inputs, and that's the output.
Did you right click?
No, I double click to see where it's going to put it. Or I could click inside the dissolve, and I would tell the output's going to be right here. So if I highlight over, that's where it's going to put it. All right, so I'm just going to run this to test it and see what happens. I'm going to validate it. You can do that if you want, and then I'm going to run it. Okay, there's going to be some problems though. Okay, if these layers aren't already in the map, you have to right-click on it and say Add to Display to get it into the map. There's my output. Do you see any problems?
Okay, the cursor.
Yeah, it's all one big giant blob. There's a few little areas. These are actually slivers. These are really, really small areas where for some reason the boundary lines didn't touch. They're mistakes. They're not real because the Public Land Survey, by definition, covers every place in the United States. But whoever created this data set somehow accidentally created little slivers. To fix that, to fix the slivers problem, we could go into dissolve, and we don't have a tolerance right there, but there's always a tolerance actually in the environments. So if I change this tolerance, I don't know how big those are. Let's see. Map, measure. Let's see how big this little mistake is. Measure distance. 0.24 meters, so 24 centimeters. For some reason, those two don't touch. They're 24 centimeters off. So I'm going to go back over to here, and I'm going to make my XY tolerance 0.2, or sorry, not 0. Yeah, 0. I said it right, typed it wrong. 0.25 meters. And what that'll do is anything that is closer than 0.25 meters, it's gonna actually get rid of it. So hopefully that's big enough to get rid of that. We'll say OK, validate it, rerun it. ArcGIS Pro is better at ArcMap at working on data sets that are already in your map. Okay, look, it got rid of those. There's one somewhere else. Oh, right there. Maybe it's bigger than. Yeah. I don't know why that one. Oh, that one's a whole 2 meters long. That's pretty weird. All right, so if we really wanted to fix that one, we could go back into environments and change this to 2.5 meters. Okay, validate, run. I'm just trying to demonstrate the tolerance. However, let's see if this kind of messed up that's what it does sometimes. So let's look at the edge. Oh, we don't have the edge. Catalog, data sets, no, folders, PLS for Marion. There we go. Marion County PLS. It looks like it did a pretty good job. It didn't mess up the edge very much at all. I don't think it messed it up at all. This is probably a pretty good way to do it. So I'm going to delete this one. So we removed those slivers. The problem is, though, still what you said before, is that we merged them all together. What can we do to make sure that we don't do that? That our model doesn't dissolve all of the polygons, just the polygons that share common boundaries. So you don't have to do this, but I'm going to show you. I got Marion right here, and I've got Lamar right here. Huh. In this case, let's see. Nope, that is the same case. Interesting. All right. It doesn't really matter for what we're trying to do, but with the PLS systems, the PLS polygons are already don't exist over county boundaries. That's not the case everywhere. Well, for example, over here in Walthall County, this PLS is partly in Walthall County and partly in Marion County, but it doesn't look like the borders. It looks like the border between Lamar and Marion and the border between Forest and Lamar always follows the PLS boundaries. So they're probably defined by the PLS system. It still doesn't matter, though. We still want to dissolve based on some unique attribute so that the polygons stay there. When we dissolve, they all become the same, but they dissolve common boundaries. Now, the problem is there are no common boundaries, but that's just with the PLS. Remember, there were some with the water bodies. But if we're going to make this truly general, that's what I'm trying to get at, we need to specify a particular column that will work. It won't always be the same column, but we need to specify a column. All right, so I'm going to get rid of those guys. Whoops, get rid of these. Remove. Wait, I accidentally removed the merged. I just ran it. Oh, no, I didn't accidentally do it. So now I want to take dissolve, and what I want to do is create a variable that is the dissolve field. So in other words, what will happen is that the user, or me, will be able to choose which field gets dissolved. So for this one, it actually doesn't matter too much, but we want to be consistent and choose a field that should represent a unique value. Remember what was it with the water bodies? It was like FID underscore NHD.
What?
Yeah, it was something like that. So here we could go in there. It's probably going to be FIDS. It's probably going to be this one. FID State Public Land Survey System. Let's look. See what this one says. I can't. I have to add that to the map. It's not going to let me do that. But that's probably what it's going to be. So let's say OK there. Now I'm going to validate and run this. And this time when I run it, I should get what I want. Yep, that's exactly what I want. So I've merged it all into one data set, and I've dissolved the common boundaries. In this case, there weren't any, but that's not a problem. Okay. So now my model works. It allows, if I change these three data sets, and I change the dissolve field, I should be able to, every time I run it, I should be able to produce an output data set that I want. Okay.
How did you get the dissolve field bubble?
I right click on dissolve and say create variable from parameter. Let's go ahead and delete it. So I'm gonna delete that by pressing the delete key. Right click, create variable from parameter. Actually, that's not the way I did it, but that does work. I think the way I did it, right, was to just go like this and actually choose it. So if I choose this, no, okay, maybe I did say create variable from parameter dissolve field. Okay. All right. Now I'm going to save this guy. Now I'm going to show you how to make this general so that you don't have to go be clicking all these bubbles, right? What if I don't want to click all those bubbles every time? What I can do is I can say these, if I right click on them and say that this is a parameter, this is a parameter, and this is a parameter, and this is a parameter, and the output I also want to make a parameter because I want that to be available so the user can choose where it's saved. Now I'm probably going to select the default, but I've made all those parameters and I hit save. Now I can, instead of running my model from there, I can double click on this model 1, and I probably should do a little bit a better job. So right now, the names that are here are what displays. I don't want them to be called that. I'm just going to rename them. Rename County 1 data. Rename County 2 data. Right click. County 3 data. And I'm going to rename this guy. Actually, dissolve field's pretty good. I kind of like that already, the way it is already. Okay, I'll just leave that there. Save. Now I'll go back to catalog. I double click it and see it tells me this is County 1's data, and I can choose a different data set. I'm going to choose I'll choose the populated places. Populated place. Populated place. And I got to make sure I'm doing the right ones. So I'm in Marion. Now I need to go into Forest and choose populated place. And I need to choose populated place in Lamar. So you need to make sure you're choosing, this is the one from Marion, this is the one from Forest, this is one from Lamar. It doesn't matter which order, but they have to all be those values. And then change the dissolve field to be one that makes sense for this data set. Okay. So my guess is it's going to always be this one that starts with FID. So FID city PL1. Okay, and then instead of calling this PLS 35 merge dissolve, we're going to call this, I kind of like that it's called merge dissolve. We're going to call this pop_PL for populated place merge dissolve. Okay. So now I'm going to run that. And now I have the populated places. Are there any populated places that exist on the county boundaries?
Yes. Pearl River and Forest.
Yeah, I mean, the only problem is I didn't really choose Pearl River, did I?
Yeah.
Purvis doesn't quite extend over there. Well, Hattiesburg does, right?
I thought it was West Hattiesburg.
What's that?
I thought it was West Hattiesburg.
Well, yeah. So West Hattiesburg isn't like isn't an unincorporated place. So this area right here and this area right here are something, but this area right here. Here, I'll show you. This. Well, what I mean is. Well, here, I'll add the laters back in here. Catalog. So if I add the populated places for Forest County in here, notice that Hattiesburg what isn't included in Hattiesburg is this part of Hattiesburg that's in Lamar County. Exactly. Now, I don't know what this is right here or that, other than maybe West Hattiesburg, but it's still not incorporated.
Those are neighborhood distinctions, like that's Bellevue, so it's not incorporated, but it's considered part of its own like populous territory.
Okay, probably not. Bellevue's like out here, right?
Is it?
This is the Lamar Park area. You know what I'm talking about?
Yeah.
Yeah. Oh, maybe this is Bellevue or Raw Springs. Maybe this is Raw Springs.
Yeah.
Yeah. Anyway, or maybe this is Raw Springs. I don't know. I don't know all my geography, but anyway, that area right there did get merged with this area right there. See this area right here, the part that's Hattiesburg? Those got merged together. Why did they get merged together? Why did, here, I'll put this on top. Why did this polygon and that polygon get merged?
They're the same FID?
Yes, exactly. So Sarah said why they got merged, like in plain English, but technically which is that they're both part of Hattiesburg. But technically they got merged because we told it to dissolve based on that FID. So if we look here at the attribute table, based on this FID underscore city PL1. So if we look at, this one had a value of 265. This one had a value of 265. Whereas this area right here, whatever it is Arnold Line. Okay, that's what it's called. Arnold Line had a value of 344. And what's this called? West. This was actually called West Hattiesburg. Okay, right there. Lamar. Mostly that's like Lamar Park area. You know, the area just south of the like Best Buy and all that area. Okay. All right. So that worked. What happens if we went in here just so that we know what we're talking about here? Here's the output feature class. Oh. Let's look. One of the things you can do, you can go to history. You can look at your model. You can open it up, and you can see the exact parameters that were run to create the output that was created. Let's say we went down and changed this to name 10 and reran this. It actually doesn't change the polygons at all. It changed the color, but it's because we ran it differently. But what changed? What do you think changed when I did that? The attribute table changed a little bit, right? Now you can see the name. So we dissolved based on two attributes that were redundant. In other words, the FID city 10, the FID city 10 was the same as the name 10. They were just providing two different types of information. One was the feature ID, the other was the name. And so when we dissolve on either one, we get the same answer. This isn't really anything that you have to turn in. I'm just showing you a few more things. So I could actually dissolve on both. So if I dissolve on both, I still get the same answer spatially, but now the attributes will contain both information. Now, if there was any areas that had the same FID but different names, they would carry through and there would be a different polygon. So I don't know why this would happen, but let's just say, here, I'll show you. So if I change this again to have the county name associated with it, watch when I run this. Now, it didn't dissolve the boundary between those polygons. So all of the attributes that are included in the dissolve field need to be the same in order for the dissolve to happen. So it's kind of like it combines them all to the same one. And if any of them are different, so now we have a 344 Arnold Line Lamar, and we also, Arnold Line is all in Lamar. Let's look at Hattiesburg. We have a Hattiesburg Forest and a Hattiesburg Lamar. All right. So in order to get the answer that we want, we only need one of these. Run it, and now we've got the answer that we want. We've got them dissolved by their their feature ID. Okay. So we could basically run this. We need to run this for both the PLS and the water bodies in order for this to run. So we already ran it for the water bodies. Well, we already did it. We did it manually for the water bodies. So there's the PLS and there's the water bodies. Huh. Yeah, there's the water bodies. There. Okay. So what we want to do now, I'll delete the, not delete it. What we want to do now is answer the question, what is the total amount of each of these populated places, sorry, each of these public land survey squares that's covered by water? All right. Do you think we need to do a union or an intersect? Okay.
I think we need to do a union because the last question asks for even an empty one.
Even what?
So the last question asks for to include even the empty ones that don't have water.
Right, that don't have water.
So would
Yeah.
we want a union?
Yes, we probably would want a union, right? Let's see what the answer would. Let's see what it looks like if we do a union. Okay, so we're going to union the what not very named very well, but the output feature class with the which is the other one? It's this one, water body dissolved. So let's call this, let's change the name here to Water PLS Union. All attributes. Yep. We're going to run this guy. And we've got our data. So this is the union of those two. The water bodies and the PLS, data. So here's one that represents PLS. Here's one that represents here's one that represents a flooded area and a non-flooded area. Can we answer our question with this information? How many polygons do we have in this box? This old box. Looks like we have, what's that?
3.
We have 3. This one, and this one. Okay. Is there any information that tells us what we need here? I mean, how would we mechanically do this? We want to find out the percent that's covered by.
Just add all the area, and the area of the 3 polygons, and then take out the 2 that are water, and then % with water.
Okay. That's exactly what we need to do. But if we did that like just by hand, we click on this one, we click on this one, we click on this one, it's going to take a little while, right? Yeah. Right. So we need to think about a way to manipulate the data so that we will get the answer that we need. All right. So what are some of the things? We talked about doing a select today. We talked about doing dissolve. and those are the major things we talked about, right? We talked about doing overlay. We just did an overlay. How about any of those other data manipulation tools? We use those to help us provide an answer.
You select all the water out, but I feel like you just put them all together.
Yeah.
If you selected all the water out, you take what's left, and then that could be your percentage.
Okay. Yeah, I mean, I think that these are all answering the question correctly, like logically, but not what we need to do in here. So I'm going to propose a solution. Okay. All right. What if we rely on what I explained earlier, that that attributes carry through even after overlay occurs. Okay. So what if the first thing that we did, number one, was in the PLS data, we create a field in the table to store the total area of each PLS. So we create a field that's not going to get updated automatically. That's just going to store the total area of each PLS. See what I'm saying? We get a new field, we have a PLS. Then, number two, we dissolve the water before we overlay. Okay. Then three, we overlay. Now if we do this, what will happen is we'll have a field that already represents the area. Okay? Then once we dissolve, then when we dissolve this, when we do the overlay, how many polygons will we have for every single PLS? What's the maximum number of polygons we can have if we do the dissolve of all the water bodies before we intersect?
Water and not water.
Water and not water, right? So we never did that. We never did the dissolve here of the water bodies so that they're all just water or not water. So we can only have two. One will be water and one will be without water. Then we do the overlay, and finally, the last step is that we recalculate area. And that's not the very last step. Recalculate area of all non-water. Why would I do non-water and not water polygons? Actually, now that I think about it, I guess it wouldn't matter, right? It doesn't really matter. It's just of either water or non-water. So of all polygons. And then 5 is that we calculate the percentage. Okay, here, let's actually do this, because I think it'll make a little more sense as we work through it. All right, so we're gonna recreate this later. So I'm gonna delete it, and this one we're not even really gonna use. So I'll delete this for now. By the way, when you delete these, it doesn't actually delete them off disk. It just makes it so it's not present. Okay, so we've got our output feature class. I'm going to rename this PLS. Okay. So I'm going to open up the attribute table. So we have a shape length here and a shape area. But what happens to those two fields when we do an overlay? Remember what I said?
They automatically.
they automatically update, and we don't want them to automatically update. We want to know what the total area of the PLS was before the boundary switch. So we're going to add a new field. That's not what I meant to press. I meant to go over to here, over to Toolbox, Geoprocessing, and say Add Field. So we're going to make a field that's going to store inside the PLS. It's going to store the area. We're just going to call, actually we're going to call it pre-overlay area. So that's what I'm going to call it. And I'm going to make it a double precision. Everything else I can leave the same. So I'm going to run it. And then I have a couple of options. I could just say this is going to equal that. So I could also recalculate the geometry, but it's easier to just say pre-overlay area is going to equal shape area. So now shape area and pre-overlay area are equal to each other. We did that. Next, we're going to dissolve the water bodies before we overlay so that they all form one single huge polygon. So we go to dissolve.
You do that.
Oh, sure.
Yeah.
So I'm going to choose the PLS. The field name is going to be pre-overlay area. And this is going to be double. And everything else is the same. And it's the warning there is telling me you already have a field called that, which is fine because I'm not going to press run. Okay. So that's all in there. Okay, good. All of a sudden I thought maybe I didn't start recording. Okay, so then we're going to go to dissolve. And if you dissolve with absolutely no parameters, it just makes everything the same. Remember, we already did that by accident when we were doing the public land survey, right? So we want to this time take the water bodies and don't put any dissolve features in. We're just going to call this output, all water, something like that. I'm going to hit.
How do you get the pre-overlay area to populate automatically?
Sorry, which one?
Like the step before when we added the field, and then how you have the pre-overlay area the same as the shape area. How did you get that to go automatically?
That when you run add field, it'll put that there.
Oh, I put a bunch of nulls.
Oh, okay. Well, then you need to right-click on it and say calculate field, and this needs to look like that.
Oh yeah.
Then run it.
Okay, thank you.
No problem. And then we need to run dissolve on the water bodies, and I'm just going to call this water all. I think I called it all water. It doesn't really matter what we call it. All right. So then, if we don't have any qualification, it's just going to run. We didn't do this last time. Let's look at the attribute table. Look at the attribute table. There's just one thing in there, and it's a huge area. So that's this one. Let's rename this. Let's make it blue. There we go. Now if I click on this blue polygon, look, all of them will light up. It's selecting the only polygon in the data set. The entire polygon. Entire data set. Okay. All right. Now, we did this. Now let's redo that union overlay. Uh, yeah.
I have to run, but I'm gonna leave this.
Okay. Okay. And we're getting close. We're
I'll have you back in for 217 whatever.
yeah.
So I'll just-
And yeah. And I'll close the Skype out when I'm done. No problem. Thanks, Sarah. Thanks for doing that thing today. All right, so we're going to do a union of the water all data set and the PLS data set, and we'll run that. So now, if we look at this attribute table, we have what we need. We have the pre-overlay shape, and we have this new shape area. Okay. So all we need to do now is calculate the percent. So with this information, how could we calculate the percent? We can either calculate the percent wet or the percent dry. The reason that I said that we should count the percent dry is why? I don't think there's any public land survey system that's 100% wet. It's like not, it doesn't exist. The lakes don't take, like, why would we even have public land survey underwater, right? Like, I mean, I'm sure I don't know if we have public land survey go out into the Great Lakes, I'm not sure. But we don't have any of these squares that take up an entire lake. And so if we count the percent dry area, then we could use that to infer the wet area. But if we did the other way around, we would leave out, we wouldn't have any of the dry area. All right, so which one of these columns here are dry? Like, could we use for dry?
Should be the ones that have water all, not honestly.
Right. So water all 1, because there's only one polygon, is wet, and these are all dry, -1. Okay. So we could select out just the dry areas. Sounds like I'm talking about dry counties versus wet counties. But. All right. So we could select out just that. So let's go select by attributes. We want to take our water union, and we want to select the water all. And how are we going to get just the dry areas? Yeah, not equal to, let's see, it's double negative, right? So just the dry areas would be, is equal to -1, right? FID water all, -1 means it's dry. So we say is equal to -1 to get it. I mean, we could do it either way. Okay, so I'm going to run those guys. And now I have just those areas that I want. And I can right click, data, export features. And I'm going to call my output class dry area. Run it. I'm going to close this one. So now if I zoom in, oh, there's water off. Yeah. Now if I zoom in, let's turn everything off so we don't get confused. But if I zoom in here, see how these areas that were wet are now cut out. Okay. Well, so let's look at the attribute table for dry area. So now I can do the final answer to my question. The final answer to my question is going to be what? I want the percent wet. I have the pre-overlay area, in other words, the total area of that polygon before we did the removal of the area. And now I have the shape area after the removal of the wet area. And they're different, right? They're not always different. Let's try to find an area with no water bodies. I don't know if that exists. Maybe. I don't see a water body in that one right there. So in that area, yep, see how they're exactly the same? The pre-overlay area is exactly the same as the shape area. But let's look at one that has a big chunk of it missing, like this guy. See how different that is? So before we did the overlay, after we did the overlay. What would be the formula for finding out the percent? We want to actually find the percent that's covered in water. So what's the percent? What's the way to do that?
Pre-overlay divided by what it currently shows, shape area.
Okay.
And then
What's the total area of the PLS? Is the total of the PLS this one or this one?
The pre-overlay is the total area.
Right. So the total area, should that be in the numerator or the denominator? Yeah, it should be in the denominator. And the shape area should be in the numerator, but if we just put that in the numerator, it's actually going to be the percent that's dry, right? Not the percent that's wet. So anyway, the formula will be, so let's just say you all took a test. By the way, we did this one. We're on this one right here. Let's say you all took a test and it was out of 57, right? So I said there's 57 total points, and your grade ended up being that you missed 5 points. So you got 5 points off. You missed 5 of the 57 questions. If I did 5 divided by 57 to determine your grade, you'd be like, no, you didn't do it right, because 5 divided by 57 is 0.08. What's your correct grade? There. It's not this. What's that?
It'd be 510.08.
Right. It's 1 minus this. And so it's actually 5 minus 57. Or sorry. 5 divided by 57. Take it positive. I don't see positive negative on there. There it is. So yeah, it's actually 0.91. That's a 1. All right? So you need to do that to get the right answer.
you also have to multiply by 100, right?
To get the percent, you're right. Right? So the general form of this is that, in our case, it would be the pre-overlay area, I'll just put that. And then the, we're just going to call it the dry area. 1 minus, and then multiply that by 100. Okay? All right, so I'll leave you guys to do that. And then once you do that, you could right-click on this and say Data Export Table. And make sure when you export this table that you save it in a format that you could get later. So you can't just put it in the geodatabase. You have to put it in a folder. So here, I'll show you how to do it, but it won't contain the information you want. So here inside Lab 2, I'm going to call this, I've got folder Lab 2, okay, and I'm going to call this output table. And it's automatically going to put that DBF extension on the end. That's fine. hit run, and you'll now have that in lab 2. So you can take this DBF file and upload it as part of the lab. That DBF file will have the information that you want. If you want to verify that it looks right, you can open it up in Microsoft Excel. And Microsoft Excel reads DBF files. So now I'll go open this PC. Where did I put it? Browse. C temp. No, CVG. There it is. Open it up. Oh, this is actually the DBF file. That says an XML document. Yeah, so I don't know why this .dbf is actually probably .dbf.xml. So open up this one that actually says that it's a DBF file. There we go, and it'll be right. Okay, so this is just so that you kind of can see that it's there. You'll need one more field on here that says percent water. That's what you'll do with this formula. This formula right here. All right. I'm gonna hit save. So when you're done, email me the toolbox. Email me this DBF file that you create, and email me the answer to the questions, and you'll be all set. All right.
Show us how to do the model on there as well.
Okay. Show you how to put the model.
Yeah, get it into the actual canvas.
Okay.
What does it look like?
Oh yeah. So on disk, like if you go to it's right here. This file.
Okay.
So so as soon as you save this and close it, I mean, you don't actually have to close it to save it, but as soon as you save it, it'll save that information in there. That's the file that I need right there. That lab 2 toolbox. So it's the toolbox that gets. You can actually save a model to a different toolbox, but by default, it's going to put it in the toolbox that was created for the project. So you could either zip them together, or Canvas does allow, right? Like you can put as many files as you want. So 3 different files is fine, or you can zip them all together into one file. Either way will work. If it's easier for you to do it and then choose the individual files, that's fine. There's no problem doing it either way. Any other questions? That was a good question.
How do you,
You go ahead, mine's specific.
Okay, go ahead.
well, how do you get from when you selected everything that isn't water? How do you create that new feature, the new thing on the content pane? The dry area. How do you create that?
Oh, so I did that in 2 steps. So I did the select by attributes first, and then I ran that, and then they were highlighted, and then I right-clicked on it and said data export features. Okay, so that'll be in the video. I could have, alternatively, instead of doing select layer by attribute, I could have just run select. I'll show you that real quick since I didn't do that before. But let's say I had select. I could take my my water data set that had everything. I'm going to clear the existing select. And then I'm going to call this dry area 2. Dry areas 2. And I'm going to make the expression the same, which would be FID water all is equal to -1, because those are the dry areas. Okay, and I'm going to run that, and it's going to do the selection and the export into a new file, all in the same tool. And so now, if I turn everything off, that's fine. So now they're the exact same layer. Operationally, they did the same thing. It looks like the tolerance was set slightly different, maybe. Nah, it's just turning it off and on. Like when you do it, it flashes a little bit. Actually, it does. Does it look like maybe the tolerance was still set the same for the other? See how it like the line like moves ever so slightly, but it doesn't really matter for this exercise. But some, yeah. You could have built this in Model Builder. Yes. So you could have built this whole thing in Model Builder, and it actually is. I mean, it is a process that gets used in GIS overlay, so it might be interesting to do. But yeah, basically, you're answering a fairly common GIS question. How much of this exists inside of these? And so this is the process that you have to do that sort of thing. Sometimes there's twists on the problem, such as, sometimes I have more than one class here. So for example, Ashley, you brought this up earlier. If this was land cover and I was interested in finding out how much forest existed in every data set, or what if I was interested in finding out how much of each land cover existed in every PLS? Okay. So I'm actually on the committee of a guy in biology right now, and he actually had a very similar question: how much soil type is there present in every PLS system? So, and you do the same thing. You do the overlay, but you'd have to summarize it a little bit different.
So, Dr. Wayne,
yeah.
There's no way that you can just ask the question in Model Builder at the end of the process, and how much water is in, let's say that output class that you did before that's how much sheet count. You can just ask the question and then give you the answer. You have to go through all the steps to break that. There's not a question you can ask or set up something in the geoprocessing to ask the question, do they want to build that one all the steps you see?
Yeah, I mean, right now, you might be able to do the steps a little bit differently, but there's no way you can ask the computer the general question, how much water is in each of those. You have to actually do the steps to get the answer. Yeah. There's no tool that says how much of each of these is in each of those. Yeah.
Okay, my question is a little bit specific to anybody that did the 3 coastal counties is that the public land survey extends into the Gulf. So
Okay.
my land number is going to be skewed some because that's not included in the water bodies.
Yeah. Okay. Well, that's fine. Let's just ignore that. Any PLS that has 100% water we'll just say doesn't need to be included.
Okay. So I don't think any of them are 100% water, but they're like they straddle pretty much like the coastline and water. So like half of them water, but it's not in that water body shape file.
Right.
Yeah.
Oh, I see what you're saying. Because it wasn't in the water body shape file. Okay.
Yeah.
Let's still just ignore it, but you're right. That's more of an error than just ignoring a problem. But we didn't have the ocean included in our water bodies, I guess is what you're trying to say. Yeah, I didn't think about that. But how could we solve that problem? Well, we would need to include those oceans in the water bodies somehow. We could merge another data set that represented the oceans into that data set. But what I'm saying is I'm not going to make you do that. I was just trying to to say, how could we solve that problem? I'm sure that we could find somewhere a ocean data set, and then we could include it in that same data set.
You could state boundary and pretty much cut the ocean or the parts of it off.
Yes, that's another way to do it. If you had a detailed enough state boundary, some of the state boundaries files that I've seen actually do include the portion of the state that's underwater in the ocean. So it wouldn't work in those cases. But some of the state boundary files just include the land portion of Mississippi. Okay. Yeah. So going back to your question, Elvis's question here. Why did I get off of it? There is a tool that I just thought of that would work for the scenario. It wouldn't work for this scenario, but it would work for the scenario that I came up with, and that was the tabulate areas. Where's did I close the geoprocessing? That's under insert, no, map, analysis, tools, tabulate area. So this one, it kind of works like zonal statistics does in spatial analysis. If you've done that before. Well, that is a zonal. Okay. I thought there was one that was a. Yeah, this might be it. Let's look at the help. It's always helpful to look at the help. Yeah. So this would. This tool would be similar, where you have your feature classes that might represent all the soils, and your zone features, which in our case would be the public land survey system, and it will give us the area and the percentage of each of those. In this case, the soil classes are just being called red, green, and blue. So tabulate intersection. Elvis, that's the answer to your question. So there is a tool that does a similar thing for a group of features. Okay. All right. Any other questions?
For the recordings of today, are they just going to go on Canvas?
Yes, there'll be a link on Canvas.